Welcome, Hornets, and thank you for joining me today. We're taking a look at the worksheet, Integration by Limits. This is pre-number 1. This is for CP Calculus and the basics for AP Calculus, and this is for individuals who are struggling and needing additional support. This worksheet currently only involves linear equations. The following, number 2, is going to be on quadratics, and then after that I have a cubics. So I'm only going to be doing 2 of these, and in this I'm going to do numbers 2 and number 4. So you'll notice number 2 is the integration from 1 to 6 of 2x minus 3, and that's where we're going to begin. So let's go ahead and write this down. We have our integration from 1 to 6 of 2x minus 3 dx, and our first step is to find the delta x. The delta x is b minus a divided by n, and this is the length of each of those segments. In this case, it's 6 minus 1 divided by n, and we get 5 over n. We now want to find our c sub I, or x sub I, which is the x in the problem. And we are going to be using a plus delta x times I. That means the x here is going to end up being 1 plus 5i over n. We now want to set up our limit. Now that means that we're working with the limit as as delta x is, as n is approaching infinity. Let's make sure I write that correctly. And I'm now going to put my 5 over n times the summation as I goes from 1 up to n. And I'm now going to put inside of my function 2, 1 plus 5i over n minus 3. Now, this is from the formula, limit as n approaches infinity, for delta x times the summation, I goes from 1 to n, of f of c sub I, or x sub I, or x, whatever you want to look at it as. And it's going to go right into the function as shown. Now, we have no choice but to do a distribution here, so we are going to be finishing with the limit as n approaches infinity, 5 over n, summation as I goes from 1 to n, of 2 plus 10i over n minus 3. This is what we're going to end up finding what we work with. And I'm going to write it in standard form so that it's easier to work with. 5 over n, summation, I goes from 1 to n, and I'm looking at 10i over n minus 1. We're now going to go ahead and we're going to distribute this piece right here to both terms inside the parenthesis. So it's going to give me the limit as n approaches infinity for 5 over n times the summation as I goes from 1 to n of 10i over n minus the limit as n is approaching infinity for 5 over n times the summation of 1. I'm going to pull out the constant 10 over n. There is no constant here to take out, so I have the limit as n is approaching infinity for 5 over n times 10 over n times the summation, I going from 1 to n of I, minus the limit as n approaches infinity for 5 over n summation of 1. Now we know these formulas already. We've dealt with them, or at least should have seen them, and we know that the summation as I goes from 1 to n is n times n plus 1 divided by 2. This is of I. Let me make sure I clean that up, please. Again, this is of I, and it is n times n plus 1 divided by 2. Now, because we're talking about limits at infinity, I can distribute this to give me n squared over 2 plus n over 2. But you'll notice that's being multiplied by 50 over n squared, which means that the denominator is going to have the higher power in the second term. That's going to force that limit to go to 0. Because of that, we are always replacing our summation of I with n squared over 2. And we can drop that n over 2 because it is always going to go to 0. We like that. So saving us a little bit of time, we will be replacing this piece with n squared over 2. This piece comes from the standard constant, which is going to give me c times n. So in this case, we're just looking at 1n. Let's go ahead and replace them now. The limit, as n is approaching infinity, for 50 over n squared. Once again, we're replacing n squared over 2. We then have minus the limit as n approaches infinity for 5 over n times 1n. The n's cancel, and the limit is now just the constant. 25 minus 5 is 20. Now, we always want to check our answers, so I recommend that you go and you turn on your calculator. Let's just clear everything out and go to y equals. You'll notice I put in 2n minus 3. Second quit. I'm going to use math 9 from 1 up to 6. And I'm going to hit alpha trace and put in y1 dx. I hit enter and I get 20. Now, if you don't want to put that into y1, you can still do it normally as math 9 from 1 up to 6. And then I'm going to put in the equation 2x minus 3 dx. Notice I get the same answer. All right? So always check your work when you finish. That was number 2. We're now going to take a look at number 4 from this worksheet. And you'll notice number 4 is negative 4x plus 7 dx integrated from negative 1 to 4. So we're going to write this down and we're going to do this problem now. And you'll notice that it's going to be pretty much the same. And my hope is that with this, you'll be able to finish the worksheet without any difficulties. All right, step 1 is to find delta x. Delta x is going to be the gap. How far to get from negative 1 to 4, which is the same thing as b minus a divided by n. So I have 4 minus negative 1 divided by n, and I have 5 over n. I'm now going to find my c sub I, or x sub I, which will be the x in the problem. This is going to be my first value a, which is negative 1, plus 5 over n times I. We now have to rewrite this, and there went my lights. You gotta love this district. So, with my lights off, I'm just gonna have to keep going, and here we go. We're gonna set this up as the limit as n approaches infinity. As we saw before, we're gonna have our delta x. Summation as I starts from 1 to n, and we're going to put our f of c sub I. This will give me the limit as n approaches infinity for 5 over n times the summation as I goes from 1 to n, and I will have minus 4 times. And I'm going to write this in standard form, 4i over n minus 1, and I have plus 7. Notice the dx is not there because it's now written as a delta x right out in front. And this delta x can go either in between the summation and the bracket, or all the way at the back, or at the front. I like putting it at the front because it keeps it out of the way and I can follow where it is. Here we go. We're now going to distribute and add like terms. The limit as n approaches infinity for 5 over n times the summation as I starts from 1 to n, and I have negative 20i over n. We have a positive 4 and a positive 7. Adding like terms. The limit as n approaches infinity for 5 over n, summation as I goes from 1 to n, for negative 20i over n, multiply plus 11. We're now going to distribute this piece to each term. The limit as n approaches infinity for 5 over n times negative 20 over n times the summation is I goes from 1 to n of I plus the limit as n approaches infinity for 5 over n times the summation of 11. Now, once again, we already know we're only replacing this right here with n squared over 2, just like we saw from the previous problem. The limit as n approaches infinity for now, let's call it negative 100 over n. Get rid of that. Over n squared. And I'm multiplying it by n squared over 2. Plus the limit as n approaches infinity for 5 over n times 11n. N squareds cancel and I reduce to minus 50. N's cancel and I'm adding 55. My answer is 5, and I now go back to check my work. We're going to put this into our calculator. I'm going to have math 9. I want to go from negative 1 up to 4. I'm going to put in negative 4x plus 7. Once again, you can put it into y equals and use y1. And there's my answer, and it confirms. Now, number 6 and 8 are following the same pattern. Okay, please be aware of that. Number 6 is 39, and number 8 is 84. So please check and see if you can get those. If you are struggling or having difficulties, please make sure you come in and see me. If you have any further questions, I am available after school and at lunch to help people as much as possible. I hope everybody has a good day, and please remember it's easy to be mean. So please, think about what you say and do. We can be mean with a thought, we can be mean with an inaction or an action, with a word or without speaking. So, think before you act. Remember, the world changes from within, and try to be nice to each other. That's the only way we're going to be able to survive as a country and move past this current difficulties. Thank you very much. Be well and be safe. Take care.